Hello, grade fives. Welcome to your first online math class. Today we're going to do a quick review of patterns. Now, for many of you, this is review, and the reason that we're going to review it today is for two reasons. Reason number one is it's now been over a week since we've looked at this stuff, and it would probably be just a good idea to refresh your memories. And reason number two is I am now taking over a large majority of the math instruction for the year. And I realized that I taught two out of the three math classes, or two out of the three homerooms of math class, but I didn't teach Miss Jackson's math class. So we're just going to take a few steps back. We're going to make sure that we're all on the same page here before we start moving forward again. So yeah, let's dive into reviewing patterns. Before we begin, I just want to share with you the learning goal for today. The goal is I can determine the pattern rule to make predictions about subsequent elements. So let's dig into this a little bit right now. And I'm just going to make a few adjustments on my settings here. And perfect. Okay, so again, let's just review what is a pattern. And there are two criteria that must be true in order for something to be considered a pattern. Criteria number one is that it is repeatable, and criteria number two is that it is predictable. So I've got two images on the right-hand side here, and I'm just going to give you a few seconds right off the bat here, actually, just to look at both of these images and to make a prediction as to whether these are patterns based on my two criteria. All right, well, let's have a look at the first one here, the one on the left. Maybe a good test to see is if I were to ask you to extend this pattern to the left or to the right or up or down, I'm willing to bet you'd be able to have a look at this and you would be able to add some more columns or some more rows because it is repeatable. We've got the same shapes repeating over and over to the left and to the right, up and down. And because of that, it's also predictable. We would be able to complete this pattern and extend it in any direction. So that meets the criteria. It is a pattern. But let's have a look at the pattern, or sorry, the image on the right-hand side here. Now, if you look really close at this, you will see that it's actually made up of a bunch of different colored triangles all stuck together there. And some people might argue that because it's made out of a bunch of triangles, it follows a pattern. But what I'm looking at here is the color of those triangles. And there doesn't seem to be any repeatability and predictability. And again, the test for that is if I were to ask you to extend this picture to the left or right or up or down, I think we would struggle to do that. You could come up with your own creation, but I don't think it would follow a pattern. It's not repeatable and it's not predictable. So this one fails the test. It is not a pattern. So let's move on here and let's talk about pattern rules. And so I've got three examples here. And first of all, let's just confirm that these are in fact patterns. Is it repeatable? Well, this starts at 2 and it increases to 4 and then 6 and then 8 and then 10. And so we can see that that increases by 2 every time. Or some of you may describe that as skip counting by 2s. And because it's repeatable, it's also predictable, which means if I were to ask you what the next figure to the right here would be, you could probably tell me that would be 12 squares. So now let's talk about the pattern rule for that. Pattern rule must include two things. It must include a starting point and the relationship between terms. So I just want to pause for a second here and just kind of focus in on this word terms here, because maybe that's some terminology that maybe only I've used, or maybe I haven't used it. And maybe you've forgotten if I have used it. But a term simply just describes, I guess, just a figure here. So this would be term 1 here. This would be my second term. This would be my third term. And this would be my fourth term in the pattern. So now that we have that terminology under our belt, let's see if we can figure out the pattern rule for pattern A here. The starting point for this is 2 dots. That's where the pattern begins. And the relationship between terms is that every term increases by 2. So if we were to write that out, this pattern rule would look like this. pattern A starts at 2. That's my starting point. And each term increases by 2. That's the relationship between the terms. So let's have a look at a second example here. Example B, I'm going to give you about 5 seconds here to have a look at this and to see if you can describe the pattern rule that you see in front of you. So go ahead and do that now. All right, here's what I described using the same format as example A. Pattern B starts at 3, and each term increases by 3. 3, 6, 9, 12, 15. Okay, let's do the last example here, example C. And again, I'll give you a few seconds to have a look at that and see if you can come up with the pattern rule for that. And here's what I got. Pattern C starts at 9, and each term increases by 9. Perfect. So that's pattern rules. Let's quickly review t-tables as well. Now, t-tables are a convenient way to represent patterns without having to do a lot of drawing. So on the right-hand side here, we've got our pattern. Again, it's repeatable and predictable, so each term just increases by 2. And because of that, we would be able to predict the 5th term over here, which would be 9. But a t-table comes in handy because sometimes patterns are really hard to draw, or maybe they're too big to draw, or the shapes are too complex. So the t-table is really your friend in helping you to summarize the important information of a pattern into a nice, easy to read table here. So you can see here, term 1, right over here, has 1 square. Term 2 has 3 squares. Term 4 has 5, and term has 7. And voila, we are done our t-table. So if I move on to the next slide here, this t-table, let me give you a pattern that we can work with. I'll just type in a few numbers here, 4, 7, 10. And maybe just for formatting here, let's center those. Okay, so having a look at that pattern that I just gave you, do you think you could use the pattern rule to figure out which number I'm missing right here? I'll give you a few seconds. All right, did you notice that from term 1 to term 2, we just increased by 3? And let's see if that's the same to go to the next term. Did we just increase by 3 to go from 7 to 10? Yes, we did. So we just found out here that the pattern is it increases by 3 every time. And if it's repeatable, that means it's also predictable. So that would mean that our next term here, 10 plus 3 is 13, just like that. Okay, one more example here. This might be more of like a real life application, because chances are in real life you're not going to get handed a t-table just randomly. Oftentimes these t-tables will have actual information on it. So let's have a look at this real life application here. Many of you are getting to that age where you're old enough to start babysitting, and maybe some of you already have your babysitter's licenses. So this example's for you. Linda charges $12 per hour for babysitting. Make a table that shows how much she would earn for each hour she works. Now, I know you're looking at this and you probably think including 0 hours of work would be useless, but it is still important information. Remember, we need a starting point. And in this example, a good starting point would be 0 hours. And if she works 0 hours, that probably means she's earning $0. And then the problem says she charges $12 per hour to babysit. So that means if she works 1 hour, she'll earn $12. And if she works 2 hours, she'll earn $24. And if she works 3 hours, $36. And so on we go. all the way to the end of the table there. So that's filling in a t-table that's completely empty on the right-hand side, just given the information in a problem. But before I let you go here, I just want to try to connect all of the information that we've learned through this review lesson. So to finish off here, I'm just going to ask, can you come up with a pattern rule to describe the relationship between how long she babysits and how much money she earns? Something important to remember is that this pattern rule must include the starting point and the relationship between the terms. So let's give you a few seconds here and see what you can come up with. All right, here's what I got. Linda earns $0 for working 0 hours. That's our starting point, but earns $12 for every hour she works. Hopefully that's what you got as well. All right, guys, thanks for tuning in to lesson number 1. We will see you tomorrow.